I think I'm going to have to add something to make that analog joystick do something. I'm going to start out in my Sprint layout software that allows me to design a simple circuit board. From there I take it into the LazyCam software, which was part of the original Mach 3 software package. Moving out to the CNC machine, here you can see the program running on the screen. The screen actually shows you real-time plotting of the tool path while it's machining. And then of course now you can see the tool bit. It's a V-shaped cutter spinning at probably in the neighborhood of 18,000 RPM, carefully engraving the traces around the back side of the board. Then I'll flip the board over and then I can engrave the letters or legends on the top side of the circuit board. Quite simple, quite straightforward. I'll have other videos to go into greater detail on how to perform these steps. It's a very simple circuit board to assemble. There's just one IC chip and the terminal blocks or screw blocks. Very, very simple, a little bit of soldering, nothing to get excited about here, and certainly nothing you haven't seen before. The core of Razzy is one large 3D printed column. It's roughly, I think, about 18, maybe 20 inches tall. Almost 10 inches square, and this allows me to mount a variety of electronic components to that core in any location. I just simply drill and tap some 3mm holes and mount up whatever it is that I'm mounting. In this case it's our analog to digital converter. And now I'll do a little bit of fancy hand waving over the keyboard and put in some commands to interpret the analog to digital controls so that moving the joystick forward actually makes the robot move forward, left, right, and so on. I'm also adding steering into it. That's always a little bit tricky, trying to get the ratio of joystick movement to work, what feels like a natural way to move and steer the robot. So that'll be refined over time as I do more and more manual driving of the robot. The sound of the motors is very good. I like how they're accelerating nice and smooth and decelerating. I think we're on to a good solution here. Test driving on the floor with the robot. Things are moving along pretty nice. The steering actually feels better than I would have assumed it would, considering I haven't done any tuning or refining of that part of the software. We'll go on now. Now that I've got manual motion working thoroughly, I'll go back and I'll test some automatic motions.
Danger, Will Robinson, danger.
And make sure the robot can move forward and turn left, right, and backward and all that sort of thing. One of the problems running the robot automatically on a tether like this, it can run the risk of running over its cords and tripping itself. And yes, this is actually the power cable going to the robot. Now he's just showing off his new aluminum mag wheels and showing off how fast he can go. Thanks for watching this video. I really hope you enjoyed what you saw, maybe learned something, or at least gained some insight. In the future, I would love to add a lot more video content in one of the many different subjects that I'd like to cover on this channel. As you could see, we cover a lot already, a lot of different woodworking stuff, robotics, electronics, CNC, 3D printing, and so on. We're hoping, with your help, that we can grow this channel to something extraordinary. It would help us out immensely, and of course yourself, because you'd be provided more content, if you would subscribe, give us a thumbs up, and most importantly, suggest to your friends they check out this channel. Hopefully we can all grow together and have a great community here of fellow makers sharing information. Thanks again for watching.